Can you see the screen now?
Yes, miss.
Okay. Then what you do is you divide by this bracket on both sides. So you have V is equal to HT plus G over TC minus TA. So remember, when you're making something the subject of the formula, it must appear only on one side of the equation, and it must appear only once. So you cannot have V on both sides and then say you have made it the subject of the formula. Then number 13, we have R is equal to Z e to the power of SW, that's a W, over KP minus 2. Okay, here we have to make S the subject of the formula. So S is an exponent, so that should already tell you that we will have to use logarithms somewhere. Okay, so what I do is first I divide by Z on both sides. So I have R over Z. This is equal to e to the power of SW over KP minus 2. And then I take the 2 to the other side. I have e to the power of SW over KP. And this is equal to R over Z plus 2. Right? Then you can take logarithms on both sides. So going to do 2 steps in one. So you have SW over KP is equal to log E, and this is also equal to log R over Z plus 2. So what I did over here is I took log of E, and then the exponent came down after I took the logarithm down. And then I will make S the subject of the formula. So you can first divide by log E, multiply by KP, and then also divide by S. So you're dividing by S. We're making the subject. Oh, this is number 13. We're making S the subject. So we divide by W and log E. So we're going to, let me change the color. Okay, so I'm going to divide by these two terms in red, and then the one in black is the one that I am multiplying by. So when I write that, I have S is equal to, I said the one in black I'm going to multiply by it, so this is KP, and then on the other side I have log R over Z plus 2. And then the ones in red are the ones I'm dividing by. So this is W log of E. And then that is my answer. And number 15. We have B is equal to Y, the 8th root of G. And then we have to make A the subject of the formula. Remember, when you have a root that is the same as an exponent, so exponent becoming the subject of the formula, we need logarithms. So first thing I will do is divide by this y on both sides. So I have the 8th root of G. This is equal to B over Y. And then I can take logarithms on both sides. So I have log 8th root of G is equal to log B over Y. And then this 8th root over here, you can write it as an exponent. So this is log G to the power of 1 over A. And this is equal to log, you can put it in brackets like that. And then the 1 over a will come down. So I have 1 over a. This is equal to, sorry, not equal to yet. This is log of g, and this is equal to log b over y. Then you divide by log g on both sides. So I have 1 over a. This is equal to log b over y over log g. Right, then we want a to be the subject, not 1 over a, so the reciprocal on both sides. This is log g over log b over y. Just a moment. Okay. Okay, that was number 13. No, that was number 15. Then number 17. Number 17, we have BC over PR. This is equal to x over y. And then you have to make R the subject of the formula. So here, I can first start by taking the reciprocal on both sides. So I have PR over BC. This is equal to y over x. And then I'm going to multiply by this on both sides. So that's multiplying on both sides. Let me use a different color. So this one here is going to multiply on both sides, and this P is going to divide on both sides. So I know what I need to do. I can do both steps in one. So I will have R, and on the other side I have y over x, and I said I need to multiply by BC. So I multiply by BC, and then I said I need to divide by P, and then I put P in the denominator. So that is how you make y R the subject of the formula. Okay, then exercise 3.8.2. This one has a lot more exercises. There's about 29 questions. So again, I will just do the odd numbered questions. Then the rest you can try for yourself. We have 1, C is equal to 5 over 9, F minus 32. I hope you can recognize that this is the formula that connects degrees in Celsius and degrees in Fahrenheit. So if you want to change from degrees to Fahrenheit, you will have to use this formula, or degrees Celsius rather. So we want to make F the subject of the formula. First thing we need to do, we will have to multiply by 9 and then divide by 5. So I have F minus 32. This is equal to 9C over 5. Okay, then I will just add 32 on both sides. So F is equal to 9C over 5 plus 32. And number 3, I have 1 over A is equal to 1 over B plus 1 over A. And then we have to make B the subject of the formula. So what I will do is this 1 over A, I can take it to the other side. So I have 1 over B, this is equal to 1 over A minus 1 over small a. And then I will combine those two, similar to one that I did previously. Okay, so I combine the fractions. So I have 1 over B, and then when I combine the fractions, the new denominator will be capital A times small a. Then this term here, I'll have to multiply it by a, small a, and then this one, I'll have to multiply it by big A. So that is my fraction. And then to make B the subject of the formula, I take the reciprocal on both sides. So I have B is equal to A over A minus A. Number 5. We have R1 over R2. This is equal to 1 plus alpha T1 over 1 plus alpha T2. Okay, so I have to make alpha the subject of the formula. So I'll start by cross multiplying. So I have R1 times 1 plus alpha T2. This is equal to R2 1 plus alpha T1. Okay, I can't seem to close my brackets, but you should close them. Okay, then you multiply out. So R1 times 1 is just R1. I have R1. And then R1 times alpha T2. So this is plus alpha R1 T2. And this is equal to R2 plus alpha R2 T1. Then do the same thing, all the terms with alpha on one side, everything without alpha on the other side. So you'll have alpha R1 T2 minus alpha R2 T1. This is equal to R2 minus R1. And then you factorize alpha out. You have alpha R1, yeah? Okay, please mute your mic then. Minus R2 T1. This is equal to R2 minus R1. And then you divide by this bracket over here. And then you get alpha is equal to R2 minus R1 over R1 T2 minus R2 T1. And that's the final answer. Now you'll notice that I have only one alpha in my final answer. It is isolated by itself on one side of the equation. So when I ask you to make something the subject of the formula, you must isolate it. It must be the only one that appears anywhere in the equation, and it must be alone on one side of the equation. That's what we mean. So you cannot end up with something like this. It is on one side of the equation, but it is not the only one. There's this alpha here, and then there's that alpha there. It must be the only one by itself on one side of the equation. Then you have needed the subject of the formula. This was number 5. Number 7, we have A is equal to P1 plus R over 200 to the power of 2 So this one looks like the equation for compound interest, except R is divided by 200 here. But in any case, we're asked to make R the subject of the formula. So first thing we do is we divide by P on both sides. So I'll have 1 plus R over 200 squared. This is equal to A over P. And then take the square root on both sides. So I have 1 plus R over 200. This is equal to plus or minus the square root of A over P. And then I will subtract 1 on both sides and then multiply by 200. So I have R over 200. This is equal to minus 1 plus or minus the square root of A over P. And then that means R is equal to the 200. When it goes to the other side, it must multiply all the separate terms. So I'll have minus 200 plus or minus 200 square root of A over P. So it did this. So this 200, when it went to the other side to multiply, multiplied that one and multiplied that one as well. So that's why you have the 200 showing twice over there. That was number 7. Now number 9. We have C is equal to 1 minus R squared over 1 plus R squared. And we have to make R the subject of the formula here. So same thing, multiply out the denominator. So I have C 1 plus R squared. This is equal to 1 minus R squared. Then multiply out the brackets. You have C plus CR squared. This is equal to 1 minus R squared. Then bring all the terms with R on one side, all the terms without R on the other side. So you have C R squared plus R squared. This is equal to 1 minus C. Then you factor out R squared. So you have R squared, C plus 1. This is equal to 1 minus C. Then you divide by C plus 1. So R squared, this is just 1 minus C. And C plus 1 is also the same as 1 plus C. I think it looks better. It doesn't make a difference really. But anyway. Then to get R as the subject of the formula, you take plus or minus the square root on both sides. And you have R is equal to plus or minus the square root of 1 minus C over 1 plus C. And then that is R as the subject of the formula. 11. We have Z is equal to pi over 32 d to the power of 4 minus small d to the power of 4 over big D. And here you are asked to make small d the subject of the formula. So first thing you can do is you can divide by pi and then multiply by 32. So you'll have d to the power of 4 minus small d to the power of 4 over big D. This is equal to 32 z over pi. Then you multiply by big D on both sides. So you have d to the power of 4 minus d, small d to the power of 4. This is equal to 32 zd over pi. And then you make d to the power of 4 the subject of the formula. You'll have d to the power of 4. This is equal to d to the power of 4 minus 32 zd over pi. And then you take the fourth root. Now the fourth root is like the square root. You will get positive and negative values. So it should be plus or minus the fourth root. So d is plus or minus the fourth root of d to the power of 4 minus 32 zd over pi. And that's d as the subject of the formula. Then the next one, number 13, we have a is equal to n, the nth root, 1 minus m over 1 plus m. And we have to make m the subject of the formula. So remember, the nth root is the same as to the power of 1 over n. So you can take power n on both sides. So you have a to the power of n. This is 1 minus m over 1 plus m. So that's what we have. Then you multiply by the denominator on both sides. You have a to the power of n, 1 plus m is 1 minus m. Multiply the brackets out. Everything inside the bracket should multiply what you have outside. So you have a to the power of n plus a to the power of n m. This is equal to 1 minus m. And then you collect all the terms with m on one side, all the terms that do not have m on the other side. So you'll have a to the power of n m plus m. This is equal to 1 minus a to the power of n. And then you factorize m out. You have m a to the power of n plus 1. This is 1 minus a to the power of n. So here again, this is 1 over a to the power of n. I will just rewrite it as 1 plus a to the power of n, just for that symmetric look. Not that it's any different than a to the power of n plus 1, because addition is commutative. The order you add them in doesn't actually matter. And then number 15. We have ln of the square root of y minus 1 plus ln of the square root of y plus 1. This is equal to x. Okay, that is equal to x. Now here we have logarithms that have the same base, so they're adding, so we can multiply the arguments. So this is the same as ln, put everything under one big square root. I have y minus 1, and then I have y plus 1. This is equal to x. Okay, and then I want to make y the subject of the formula. So I need to get rid of the ln. Now the way we get rid of the ln is not by dividing by ln on both sides. What we do is we write this in exponential form. So the base of ln is e. So I have e to the power of x This is equal to the square root of this. Now, I'm sure you'll notice that what I have under the square root is a difference of squares. So I have e to the power of x. This is the square root of y squared minus 1. Then to get rid of the square root, I square both sides. So I'll have e to the power of 2x. Okay, somebody's in the lobby. Let them in. Okay, so e to the power of 2x, because it's e to the power of x to the power of 2, those two should multiply, and then you have y squared minus 1. Then you make y squared the subject, so you have y squared. This is equal to e to the power of 2x plus 1, and then you take plus or minus the square root. So y is equal to plus or minus the square root of e to the power of 2x plus 1. And you were on number 15, now number 17. We have a over b to the power of minus x. This is equal to b over a. And then we have an exponent that we want to become our subject. So we have to introduce logarithms. So I have log a over b to the power of minus x. This is equal to log b minus a. Now this b minus a, I cannot split it up because there's no law of logarithms that say anything about that. So I cannot make this log a minus log b. That is not correct. So I have minus x log a over b. This is log b minus a. And then I want x to be the subject of the formula, so I'm going to divide by the negative log a over b. So I have x is equal to negative log b minus a over log of a over b. So that's what I have. Number 19. X over y. This is equal to ln of m minus n minus ln of m plus n. Here I have to make n the subject of the formula. So I have two logarithms. The bases are the same. Both of them have a base of e. Then if I want to, I can combine them. And it's a subtraction, so I have to divide the arguments. So I have x over y. This is the same as ln of m minus n over m plus n. Then I will rewrite this in exponential form. So I have e to the power of x over y. This is equal to m minus n over m plus n. And then I will multiply the denominator out. So I have m plus n e to the power of x over y. This is equal to m minus n. So multiply your brackets out. This e should multiply all the terms inside the bracket. So we have m e to the power of x over y plus n e to the power of x over y is equal to m minus n. Then again, all the terms with m on one side, everything without m on the other side. So I have m e to the power of x over y minus m. This is equal to minus n e to the power of x over y minus n. That's what I have. Then I factor out m as usual. So I have m e to the power of x over y minus 1. This is minus n e to the power of x over y minus n. Then I divide by the brackets. So I have m. This is equal to minus n e to the power of x over y minus n, and then I divide by e to the power of x over y minus 1. In this, I can actually rewrite it like this. This is n e to the power of x over y plus n over 1 minus e to the power of x over y. So you can take a look at that one and then try and figure out how did I change from this to that. The only reason I changed it is because it looks better. We usually don't like to have all negative terms in the numerator. Yeah?
Miss, I
Yeah.
have a question.
Yes.
On the other side, where the negative n to the power of e x over y minus n, can't you also factorize n there?
You can, but why?
So that both these two brackets can cancel each other when you're going to divide on both sides.
How will they cancel each other out? If you factor out n, you'll have negative e to the power of x over y minus 1.
On the other
How will they?
side,
Hmm?
on the other
Do
side,
you,
where there
do
is
you
n.
mean do you mean over here? Can I not
Yes,
factor? Okay, if I factorize n here, do you see this negative here?
yes.
The e will remain negative. This e here
Okay,
is positive, so they cannot cancel. Is
okay,
that
miss.
fine?
Thank you.
Okay.
Yes.
Okay. Then that was number. I forgot. I cannot see. That was number 19. So we do 21. So 21, you have K is equal to 30W squared over 2G. And we are asked to make G the subject of the formula. So this one is very simple. You just multiply by G on both sides and then divide by K. So this, I can just do it in one step. G is equal to 30W squared over 2K. So nothing complicated about that one. Then 23. Then we have d to the power of 5 is equal to KL, and then we have v over 100 squared. Excuse me. We have to make v the subject of the formula. So we can start by dividing by KL on both sides. So we have v over 100 squared. This is equal to d to the power of 5 over KL. Then you take plus or minus the square root on both sides. So v over 100, this is equal to plus or minus the square root of d to the power of 5 over KL. And then you multiply by 100 on both sides. You have v is equal to plus or minus 100 times the square root of d to the power of 5. This is d to the power of 5 over KL. Then number 25, we have Z over K is equal to A e to the power of minus x y. Okay, we have to make x the subject of the formula. So again, here x is my exponent. So I know that I will have to introduce logs, excuse me. So I start by dividing by a on both sides. So I have e to the power of minus xy. This is equal to z over ak. And then here I'll take log on both sides. So I'll have minus xy log of e is equal to log of z over ak. So I've done two steps in one here. So if you cannot see it, do step by step. There's nothing wrong with that. Okay, and then I will divide by negative y log e on both sides. So I have x is equal to negative log z over ak. This is all over y log e. Number 27. Number 27, I have I sub t. This is equal to EMF sub t over,
But ma'am,
yeah,
um, oh, the last equation that you saw, why
yeah.
did you make x is equal to negative log open bracket t over ak? Why did you make the term negative?
Which one is that?
Yeah, that one.
This one here. I
Yes.
divided by this negative.
So okay,
Yeah,
okay, miss.
yeah. So I think we can do just one more. This is RT plus small r over t. Okay, so I'm guessing this is some physics formula, no EMF, electromagnetic field or something, I don't know. But you guys should know. Here we are asked to make small rt the subject of the formula. So what we do is you just cross multiply. This is I sub t. This is r sub t plus small r sub t. This is equal to EMF of t. Then what I will do, multiply out the brackets. So I have I t r t plus I t r t is equal to the EMF of t. And then I have I t r t. This is equal to the EMF of t minus I t r t, and then I will divide by I t. So I have R t. This is equal to EMF t minus I t R t over I t. And that's it. Okay, so the rest you can go ahead and try them and see what you get. So it's all about practice with these questions. The more you practice, the better you will get. And with all the questions, there is nothing that you will be asked to do that I have not done. So whether it's factorizing x out, or it's making the exponent the subject of the formula, everything is pretty much the same. Okay, do we have any questions before we go? We're a little over time. No, we're just on time.
Miss,
Yes.
which book are we using?
Is it fine?
Miss,
Yes.
which book are we using?
What do you mean?
Which book are we using?
Oh, these are the notes. If they're not on e-learning today, I'll post them there in that green book that I put on e-learning. You'll find them there.
Okay.
Yeah. Okay, so have a good day. I'll see you guys tomorrow at 1:30.